Greetings, everyone. It's Alex once again here at 12:09 a.m. on Friday the 30th, the day before Halloween. Um, Voting time is coming up this Tuesday. Happens to be my birthday as well. I'm going to spend the day at the polls helping people get their votes cast. Um, and then maybe sometime after that, when I get done, I can celebrate the birthday with the fam. But until then, this is the second part of, well, not the second part. Let me give a disclaimer. I made a video about inserts and updates, and when I went to go back and look at the video, there was no sound because I forgot to turn my microphone on. So this time, I have turned my microphone on, and I can verify that I've seen levels there. So I did all that work, so this will be a little bit of a shorter video because all of the work has already been done. Down here, you see I am actually updating my SQL Server Management Studio. So I'm downloading SQL Server Management Studio over here right now. Um, so let's go ahead and get started here. So the first thing that I did, and I'm going to go ahead and open up this script that I have over here. Open up our schema right there. And this schema file was the original file that we used to install all of our databases for our bike stores database. I'm sorry, install all of our tables for our bike stores database. So if you remember in the very first videos, we installed Visual Studio, SQL Server Management Studio. We installed we created the bike stores database, and we ran the insert on all of these objects here. So down here on the very bottom, what I've done is I've created a table called backorder items. And I'm going to go ahead and it's got data in it. So I'm going to drop that table. Delete this table. Say okay. There we go. And if I refresh that, the table is no mas. So what we're going to do is we're going to run this script here, creating our backorder items table. And what our backorder items table is going to tie into, it's going to tie into our sales orders table with a foreign key of the order ID. And it's also going to tie into our production.products table, and it's going to use the product ID. So we've got two foreign key constraints, and then we've got our primary key is going to be our item ID. So we're going to go ahead, select this, and run it. Bam. And then we'll come back behind here, and we'll run these two key constraints. We'll refresh our database over here, and our table is now there. So that's the first couple of steps there. The next step that we need to do is I close the schema. The next step that we need to do is we need to get data into our table. And this is where we are talking about the inserts. I'm going to go ahead and open up my other file. So that's what I used there. You know what? Let me go back and look at that real quick. You know what? I need to delete that table again. Delete that table. Say OK. And let's come over here because this is the one we used right here. We created a backorder ID as an identity field. So what we're going to do is we're just going to run this right here. And execute. Come over here and refresh. Got our table right there. We've got our keys there. Now let's take this information, copy it, and get rid of this right here, because that's not right. Ooh. Control V. And we'll save our schema. Bam. And we can close this. Now what I've done also, I believe this is the, yes. No, that's the previous lessons. I've got to find where I made this at. There we go. So in the previous video, or in the video that I did not record the sound on, I talked about the operations of a database. And so there are 4 basic operations that you have to understand that a database will do. It also pertains to rights, to user rights of a database system. At the user level, you can have create rights, you can have read rights, you can have update rights, and you have delete rights. So an idea of what each is, a create, or CRUD, this is the acronym CRUD. Create is basically an insert, records, rows, I should say, rows. Let's use the right terminology. That's an insert, and you use an insert to create tables and rows in, or insert rows. You can use insert rows into a table. You can create databases, create tables, yada. Read is your select statement. It's going to read rows from a table. Update is your update statement. And that's going to take an existing row in a table and it's going to update that row with some, it's going to overwrite that with whatever you put in there. And then there's delete, which is straightforward delete. You can delete tables, rows of data, you know, columns in a table, yada, yada, yada. So the example that I gave for today is an insert or create rows. And we did create the database already. So what I'm going to do is I'm going to insert rows into a table using a select statement. Now, what this does is it ties or it grabs information from different tables, excuse me, and it combines them into a data set or uh, uh, a return set of rows. And I'm trying to remember the right terminology there, y'all. It'll come back to me. Um, Result set, I should say. And then what happens is it creates your table on the fly. Otherwise, you'd have to have, let me go back to that other schema, this one right here. Otherwise, you'd have to do something like this. And you don't have to do that every single time. You have to put that into a table. So if you've got existing tables and you've got the data that you want in all those tables, you can combine all of that data into a select statement and populate a new table with it. Now, the table that you populate has to match the rows or the columns in your new table. So here you see my back order items table that I created. And you'll see I have a back order ID, an order ID, and a product ID. You can see that these are foreign key constraints because there's a hollow key, and a solid key means a primary key for that table. And then you have product name, order ID date, back order date, and back order quantity. So now, if we look at our query over here, we have insert into our table, and then we have the columns of that table, order ID, and they just match what you see over here. Let me make that a little bit bigger. Order ID, product ID, product ID, and so on and so forth, right? So then we're going to use our select statement, and we have to have the same number of columns in our select statement that we have in our insert statement. And I'm grabbing the order ID, the product ID, the product name, the order date. I am creating a new column here called back order date, and I'm populating all of the rows in the table in that column with the same date, and then a back order quantity, which is just going to be a sum of the items ordered that I want to put on back order. So the next thing I'm doing is this is my select statement, and you'll see that I'm doing a join on the production.products schema and table, and I'm grabbing the product name right there, and then I'm also joining on sales.orders, and I'm grabbing, I believe the quantity, no, the order date, I believe comes in from that table. And I'm doing a conditional saying I only want to back order, put the back orders of product ID 20 in there. I'm grouping that by the order ID, the product name, and the order date. And then I'm doing sorting it by the product ID from smallest to largest. So if I want to test this, just this, I can just highlight this and not do the insert. Say execute. And this gives me all of the stuff that I ordered, that all of the item 20s that are going to be on back order. It also tells me what order ID that item belongs to. 1, 2, 3, 6, 8, 13, 17, and so on and so forth. I've got 84 rows that match that criteria. So now, the next thing I'm going to do is I'm going to type in a command which will put the table into a write but not finalized status. I don't know how else to explain that. It's called begin tran. So what this does is it says, hey, I'm going to start this transaction. I'm going to do this logic. And unless I commit my changes, these changes are going to be basically um, not checked in. They're not going to be, they're going to be a working command until I commit my transaction. So the command to do that is commit transaction. Or you can just put commit tran like that. And then there's rollback tran. And you use rollback if your results do not match what you want to do. So underneath all of that, let me grab this and move it up here. Because what it's going to do, it's going to do our select statement, our insert and select from with a select. It's going to do that, and then it's going to select the items that I put into the table, and I should see this, what I'm looking at right now. And then once I see that, then I can just highlight commit tran and run it, and it will commit my transaction to the database. That's a great way to keep you from messing up rows in a table, because once you commit your transaction, you can't get those changes back. They're permanent changes to that database unless your database is backed up on a regular basis. So let's go ahead and run this and see what we get. I'm going to go ahead and not highlight any of this code, or this query language, I should say. I'm going to hit F5, and it gives me my 84 rows, and I got back what I wanted to get back. And I know that that's in this table because I did a select statement there. And if I come over to messages, I should see 84 rows inserted and 84 rows selected. There we go. Yep. Now I can do commit tran, highlight it, hit F5. Comment this out. And now my rows are in this new table over here. Now if I try to rerun this SQL statement here, I'm going to get an error. No, I won't get an error, and I'm going to tell you why. Actually, I will get an error. Well, maybe I won't get an error. Well, let's run it and see. Nope. It actually doubled our list. So what we're going to do real quick, because I didn't want that to happen, I'm going to do a delete statement real quick. I'm going to say I knew that I had 84 rows, so I want to get rid of rows 85 through 168. And that's real simple. I can say delete star from sales back order items where, you don't want to put a no luck on this one, where back order ID is between 85 and 168. Get rid of that right there. Let's see what happens here. 84 rows affected. Delete that. Run this SQL real quick. Should only have 84 rows in the table, which I do. So that was a delete statement. Real quick. Sorry, real quick and dirty. Keyword is delete. From table tells you where. Where is your conditional that you want to filter on, and say I only want to delete the rows where it's between these numbers and only those rows, and that does your logic. I mean, that does your delete statement. Deletes are very simple to use for the most part. Now we have an update statement here. Let's say we want to change the back order date in here. So what we can do is we can take our update statement. We're going to say update the table, which is going to be our sales.backorder items table. Update that. We're going to set, so let's say our back order date's going to change. So now instead of items coming off back order on the 1st of November, items are going to come off back order on the 1st of December. So we're going to say set back order date equal 2020-12-01, and we're going to say where product ID equals 20. And if we hit F5. We have 84 rows affected again. And now if we do this select statement up here, we should have 12/01/2020 for our backorder date. So that's how an update statement works. You're updating the table, you're setting the column to the value you want, where your conditional is true or false. Whichever your conditional you want there, um, it's your filter. So we've done all four phases of our SQL statements, CRUD. We've done creates, reads, updates, and deletes. So this query is pretty much done. Get rid of that. So let's say I want to insert one row into our table. Instead of doing this insert statement the way I'm doing it, I'm going to tell you there's a really easy way to do this. To perform a task that you want to repeat over and over again, but you don't want to have to keep writing the SQL query for it. That is called a stored procedure or stored proc. We can take this logic here and we can use disposable values called scalars, and we can replace those disposable values or the values that we're going to use here with a disposable scalar value, a variable, and we can change how our insert works, and we can use that as a function and call one line of SQL to execute our stored procedure instead of rewriting all of these lines of SQL every time we want to do this. That's one way to do it. You can also use functions. You can use database triggers, which are more complex. You can do all of that. So there's multiple ways that you can get data in and out of tables and manipulate data. So, and I say so a lot. I shouldn't say so a lot. So, and I said it again. Here we go. We'll select the top 1,000 rows. We only have 84 of them in there. We've got an identity field that will continue to increment. We've got all of our order IDs in here. So there's a method to our madness of what we're doing here. I'm showing you this SQL and this SQL, a bare bones basic primer here, because what we're going to do eventually is we're going to use an object relational management software called Dapper. And it's very simple to use. Let me pull up Dapper. So there's multiple ones that you can do, that you can use. You can use Entity Framework, which to me is super complex and very, very time consuming to use. Or you can use Dapper. It's so easy to use. Dapper is so easy to use. Dapper ORM. And so there's a tutorial out there that you can learn how to use Dapper. And yes, it is much better than Entity Framework, and that's just one man's opinion. We'll talk a little bit more about SQL Injection later. Let's see here. So there's different things that we can do with Dapper, and we'll use Dapper to do what we're going to do. But the reason why I'm showing you all of this is because eventually what we're going to do is we're going to build a .NET console application or a .NET um, Windows Windows Forms application. Real simple. I'm not gonna build an entire web page. Well, I guess I could build a web form for this too. Probably a web form. Probably easier. Um, you can build a web form or whatever you're gonna use, and then what you do is inside of your code you call your SQL um, store procedure. One line of code. You execute your store procedure. You send stuff to the data. You send your query to the database through your store procedure, and then you get back your data, and you can parse that out and do whatever you need to do with it. So we're gonna eventually get to that point, but I needed you all to be able to do some very bare bones basic stuff in SQL um, to be able to use to go where we're trying to go here. I don't expect you to be SQL, SQL, DBAs, or you know data scientists overnight. I'm only showing you the primer of this to get you kind of familiarized with how SQL works and how it looks. But the onus is on you to go and do some hard work and research on your own and learn this stuff on your own as well. Um, but these videos hopefully will give you a good jumping off point to be able to do what you need to do. I'll show you a few more tricks in SQL before we go any further. Let's see here. One thing that you can do in SQL is you can copy, and I think I might have showed this before. You can copy all this information with headers, put it into an Excel spreadsheet. Um, there's other ways that you can export reporting. Excuse me, you can build a crystal report for it, but I don't have any of that stuff installed right now, so I'm not going to bother with it. Because you have to have SQL Server reporting services, I think, installed on your machine. And then basically, SQL is just your way to manipulate and to get into the actual data, to look at it, to create reporting off of it, to put new records and rows into your table, to delete the ones that you don't need, to search them and return the value set back to a user. You have to know SQL to be able to do that in an SQL server. Now, there's other types of SQL servers. There's Oracle, there's MySQL, there's Postgres, I think it's called. And there's obviously Microsoft SQL Server. Um, SQL is almost the same across the board, the syntax of it. There's different keywords and stuff for, individual databases that you're running. But for the most part, the SQL looks basically the same for everybody. um, let's see what else. You can also, let's just do some really quick stuff here. If you want to practice without having a table over here, you can just open up your SQL Management Studio here, and you can do this. You can say, what does it look like when I do a select hello world? Oh, not double. What happens if I do that? Well, it types out hello world. Well, what if I type hello world as field? And I've got a column called field, and it outputs hello world. Let's say I want to grab a specific, scalars. We were talking about scalars. Scalars are basically, and I may have covered this a little bit earlier, but basically scalars are throwaway variables that you can use and create. You declare a scalar by saying declare. Scalars are usually identified by the at symbol, and you give it a name. So let's say test, well, let's call it hello world. Zoom in just a little. And we're going to call this a varchar of 50 equal, and we can do it that way. You can initialize it this way. Initialize it this way, and then just say select at hello world as field. I'm going to hit F5, gives me my hello world there. If I type hello cruel world, and I hit F5, it obviously types it out. You can do this with any type. You can create a scalar for any type that you want to. You want to do a date, declare a date scalar. Twenty, 10, 30 at date. And let's get rid of this. Hello, cruel world, and I've got today's date in there. Another way you can do this is if you don't want to initialize it, come down here and say set at date equals that, and you still get the exact same thing. Like I said, you can do that with anything. Let's say I want to cast, and what casting is making sure that you are treating a variable or a type of a variable like that type of a variable. So for example, you cannot put numeric data into a field that's only meant to hold numbers or dates. You can't put that in there like that. You've got to cast it the proper way. Casting is something that is quite common to every development software system out there, every development language, SQL, you know, it's commonplace to um, it's commonplace to I'm drawing a blank here. Oh yes, casting. It's commonplace to cast in whatever language that you're messing around with. I'm half asleep now all of a sudden. But casting is very important because you don't want to have errors in your code. So for example, if I create a bit declare some bit, get rid of that, and I try to set at some bit to a string variable, ASDF semicolon, and I say at some bit, I'm going to get an error because I cannot take alphanumeric data and put it into a bit data type. Doesn't matter if it's a bit, if it's a long big int, I can't do that because you can't stuff alphanumeric data in there. You can stuff numbers into a alphanumeric field, but you have to indicate that it's a alphanumeric field by putting in the colons. I mean quotation marks, single quotes. So what you wanted, and then the other thing about creating scalars, and I'm about to reference one of my coworkers here. I talked a little bit earlier about SQL injection, SQL injection. SQL injection is basically how hackers can hack into a web page that uses SQL behind the scenes by basically creating queries and testing those queries out on your web page or a web page that uses SQL. And what happens is they can gain access to the table structure in your database by faking out or overriding the SQL that comes into your SQL query. And they can get passwords and usernames and stuff like that fairly easily. There's a video that I watched a few weeks ago about SQL injection. I have a project that I'm working on at my job that, and anything that you do, if you do it professionally, you have to protect against SQL injection. The easiest way to do that is to use declared scalar variables, parameterized variables in store procedures and in queries. Because you can cast those queries a specific way and protect your SQL from SQL injection. There's other ways to do it, but the easiest way is to use parameterized queries. We'll cover that again in another video because it's a very long topic to talk about. But you always want to use parameterized queries under SQL. What do I mean by that? So let's go back to our SQL query that we had earlier. Right here. See, I've got this stuff hard-coded in there. What would happen if somebody changed my SQL on the fly and changed this to 2020? Well, what's going to happen is my SQL is not going to work anymore. So, to make a parameterized query, you declare your scalars up here. And I'm going to declare at product ID equals, this is an integer I think, yep. This is int. And then I'm going to declare at param prod ID. And this is going to be an int. Okay. The way this works is this would be the parameter ID that I intake from the user. This will be the parameter ID that I will be able to use in my query down here. So let's make this a string instead, or a varchar. Varchar. Oh, let's make it a char. Char. Let's make it 3 bytes long. Right. Now, what I can do is I can do some conditionalizing on this right here, and I can say cast set at product ID equals cast at param as int. So if I type in, if I come up here and I say select, or I say set at param equals select from blah, then what's going to happen if I try to run this? It'll throw me an error because I can't, since I'm casting this, this cast won't let you do that. It only returns an integer. And what that does is it puts a layer of protection between my query down here and whatever somebody puts in up here. It makes them put in a number. So if I come over here and I say 2, and I hit F5, and actually, I'll come down here and say select at product ID. And run that, I'll have a 2. So you see how that protects? Select from sales dot back order items. See, that protects my query, and it prevents SQL injection. That one simple thing prevents my site from getting hacked. So I'll get rid of that. And then what I can do is, I believe you can check the type of, no, I won't go that far. Get rid of that. So now down here, instead of using the 20, I can say at product ID. Like this. So now, if I come down here and I pass in set at param prod ID equals 10. If I come down here, instead of doing the insert, let's get rid of the insert real quick. We'll just move it up above a little bit there. So hit F5, it gives me 10. If I put 11, hit F5, it gives me my 11s. Let's say 100. There's 28 of them. Let's say where 100. Error. And that's what you want. So again, it gives you a layer of protection against SQL injection by using parameterized queries. This is a parameterized query right here, where my query is going to use this parameter, which is protected from that parameter, where I can put junk in there. It puts the kibosh on anybody doing anything nefarious on my website or in my application. So we talked a little bit, like I said, we did a delete statement. We just talked about updates. We talked about updates. We talked a little bit more about creating and reading, or CRUD as a whole. We talked about parameterized queries. We talked a little bit about an ORM we're going to use later, which is Dapper. We talked about stored procedures, and we're going to create a stored procedure soon here. Yeah. So it's getting late. I'm getting tired. And so I'm going to end this video now. It's a little, like I said, it's a little shorter than my last video, but it is going to end here. And so hopefully you learned something. Hopefully this helps you. If I sound like I'm rambling, it's because my eyes are droopy. Until next time, peace and God bless.